Hi, my name is Vaibhav, and today we'll learn about functions. So functions are a very important concept both for your engineering entrance exams and also in order to understand various concepts in mathematics. It's a very fundamental concept, and it is used to describe a lot of phenomena in both the physical, chemical and other phenomena that happens in the real world. So, and also a lot of chapters that you will learn further on, such as like limits, derivatives, continuity, and like be it any other chapter in mathematics, knowing functions is very important. So it's a very fundamental chapter. It has various definitions and a lot of use for the next topics that you will learn. So we'll start with an intuitive definition of functions, something which we'll try to understand using examples, and then we'll try to go into a more mathematically precise definition. So functions are used to describe a special relation between two variables. So here the word relation is a mathematical concept that we'll understand later, but this is a very intuitive concept where like what we are trying to see is we have two variables of interest and we are trying to define their what is the relationship between them. And that is something which is important in a lot of places, because you always have something such as an input to a system and an output to a system, and you want to figure out what the system is doing, and functions come in handy at that place a lot. So this is a very intuitive sort of description of functions, and in order to define it for our use, we like mathematicians use different types of descriptors for functions, and typically functions are described using a graph, a rule, or an equation. And now we'll see like how this is done. So like when you have two variables, either you can draw a graph, draw a plot to show how they are related, or you can have a very intuitive rule which you can very easily describe, or at times, like as we'll see in more and more, we'll be using equations to describe a function. So let's begin with a very simple example. We'll take a life of a typical student who's studying for an exam and going to school, and we want to figure out how his or her day goes. So let's call that student Sonu, and we want to find out how Sonu's day went, and the variable that we are interested in is how far Sonu is from home. So variable 1 that we'll select is time, and variable 2 will be Sonu's distance from home. Now let's go to our first definition that we wrote. So first description for function is a special relation between two variables, and here what we have are two variables of interest. One is time of the day and how far Sonu is from his home. So let's try to make a plot for like a typical day. I'll try to remember how my school days were and try to make a plot based on that. So I'll just divide. So on x-axis, I'll draw time of day, and on y-axis, I'll draw distance from home. So we'll count time from midnight, so 0 and in 24-hour format. So 0, then let's say 5, 10, 15, 20 and 24, because the day has 24 hours. And then we want to figure out how the day went. So in morning, Sonu was at home till 6 o'clock. Then he went to school. So the distance was some distance, how much far the school was. And then he was at school till roughly 2 p.m., which is 14 hours. Then he went to a friend. Then let's say he goes to a friend's place, spends some time there, and then comes back to home, and then spends the rest of the time at home. So here we see that very intuitively we can describe relationship between two variables using a plot. And this plot essentially is describing a function of where Sonu is throughout the day, like how far Sonu is from his home throughout the day with respect to the time of the day. So similarly, we can draw up such graphs or such relations for different variables. So taking an example from physics, let's say we want to study a similar thing but for an object which is moving with a constant velocity. So let's take another example. And if we want to draw a plot of the distance of this object from the starting point, it will be something very similar to this. The nature of the graph will be different, but essentially we are plotting similar things. So again, variable 1 will be time, and variable 2 will be distance from start. And we know if an object is moving with a constant velocity, it can be described by an equation, which is, let's say we describe variable 2 using the variable d, and this is described by t. So d will be equal to, and let's say the speed is 1, which is given. So 1 times t, where t is in hours. So now this is an example where we describe the function with an equation. So we saw that a function can be described by a graph, a rule. So at first the rule was where you are from home, or it could be a rule like object moving with constant speed. And then at times we also use equations, and they are interchangeable. So here we can write this rule as an equation and this equation as a graph. So let me try to draw a straight line, and this is how the distance varies with time. So these are some examples of functions which occur in like day-to-day activities, and in these examples we see that the function's input is the variable 1 was always time in both of these examples, but that doesn't have to be the case. Functions can have different notions of variable 1 and variable 2 depending on the application. Another interesting way to look at functions is as an input-output relation. So here in the examples that we studied, we had two variables, and we can also think of them as a relation between input function, which goes through a function, and outcomes output. So in example 1, input was time of day and output was distance from home. Similarly, in example 2, the input was time in hours and output was distance from starting location. So we have seen multiple ways of intuitively describing the function. So either it could be a special type of relation between two variables, which could be described using a graph, rule, or equation. It could be thought of as a system which converts an input to an output, and that is and whenever we have anything of this sort, we can use functions to describe them. Now, once we have these functions, they are very useful, and they can be manipulated to figure out a lot of properties of the system. So far we have seen a few examples. Now I would request you to take some time to think about other functions that you encounter in daily life. So for those of you who like sports, you can think of something, let's say in cricket. Your favorite batsman hits a ball and you want to figure out how fast the ball is moving. So you can have time after which the ball was hit and the speed of the ball. And it doesn't have to be anything to do with speed or time. It could be something altogether different. So let's say you are traveling in a train from Bombay to Delhi, and at Mumbai 20 people ride on the train, and then the number of people changes every station. And based on the distance from Mumbai, you can figure out the number of passengers in the train. So in this example, in the train example, so distance is the input variable, or variable 1, distance from start, and output variable is number of passengers. And similarly, you can make other functions. You can find other functions in your day-to-day activities, and they occur in almost all physical and in various physical and chemical phenomenon. And so a lot of things that you are learning in physics and chemistry are also functions are also useful there to describe those phenomena. So again, take some time to think about examples of functions. And also one thing that is very important to see here is what makes variable 1 go on the x-axis and variable y go on the y. So is it possible to flip time and distance from home in this graph? So think about why variable 1 is on x-axis and variable 2 is on y-axis. One reason you could think of is variable 1 is sort of input and variable 2 is output. But there are other reasons, as we'll see as we go ahead. So this was a very intuitive definition of functions. Now let's try to see it from a mathematically precise perspective. So for that, we'll go back to our original statement that functions are used to describe a special relation between two variables. So here we have a few mathematical terms. We have relations and we have variables. And we'll try to see how they relate to the mathematical concepts that we already know. So one thing that you have already learned is sets. Sets are a collection of items, and so let's say we have a set A and B, where A could be any object of interest and B could be another set of object of interest. And let's say we denote elements of A by A, small a, and elements of B by small b. So once we have this set, we have variables from these sets, and we can use and whenever there is any relationship between these variables, we can define them using certain mathematical constructs. So one construct is a Cartesian product of two sets. So a Cartesian product of two sets A, B is given by A cross B and includes all the elements A comma B. So let's say if set A has two variables, let's say A1 and A2, and set B has one variable B1, then A cross B will have three variables, because A1 comma B1, A2 comma B1, and it will have two variables as well. But if set B had another variable B2, then the additional variables will be 4. So a1 comma b1, b2 and a2 comma b2. So Cartesian product of two sets essentially includes number of elements from set A multiplied by number of elements from set B, and this is a very big set, and a relation is defined as a subset of the Cartesian product. So let's say for some reason you are only interested in a subset of this Cartesian product set. We let's say call it by R. So this R, let's say, has a1 comma b1 and a2 comma b2, and so this is any subset of the Cartesian product is a relation. So now we have defined some of the quantities that we needed to know in order to sort of understand our intuitive definition of functions. And now that we have defined like the important concepts that we need to define our precise definition of functions, we'll see in the next lecture how we combine sets, Cartesian products and relations, specifically relations, to figure out what is special about functions.